Hi, everyone. Welcome to BlinkOn 14. Thanks so much for joining. I'm Penny. I'm a product manager on the Chrome Web Platform team, and I'll be emceeing today. If closed captioning is helpful for you, you can enable it in the bottom toolbar of this video chat app. Just look for the CC icon with the Turn On Captions hover. This is our second virtual edition for BlinkOn. It's good news that in some places the threat of COVID is receding and people are returning to the office. But for many of us, the extraordinary personal and professional toll of this pandemic is still ongoing. So please be extra kind and understanding with your fellow attendees. They may be facing very difficult situations. For some of you, this event is taking place really early in the morning, and for some of you, really late in the evening. Wanted to thank everyone for that. I'd like to urge you to be as present as you can be throughout BlinkOn. Something you might have noticed is that the event is now 3.5 hours per day, over 3 days, with shorter breaks. We're trying this format to make it easier for everyone to sustain engagement with the event. If you're not in a session, please do consider participating on Slack. We've made some other improvements from the feedback as well. For example, captions and transcripts are now going to be human generated and added to the videos in YouTube within the next day or so. We've tried to make the schedule and events page easier to use and more searchable. The chance to speak with so many Chromium developers only comes twice a year, and a lot of people have cleared their schedules in order to participate. Consider giving email a rest for a few hours over the next 3 days, and use the time to get to know your fellow participants and the projects they're working on. We can't virtually recreate all the same opportunities for ad hoc discussions as is possible in person, but with your help, we can make the best of it. If you're able to do so, do stretch, shake it out, take breaks, do your best to sustain the attention. A couple of housekeeping items before we get started. There is a code of conduct. Please have a look at this in the FAQ. The contact information for reporting a COC issue is in the FAQ as well. Your feedback is very important. The planning committee is welcoming that anytime. We will send a form when the event is over, but you're also welcome to reach out to us in real time through Slack. You can find us in the BlinkOn Help Desk channel. There's going to be a post-event survey, so please do fill this out. And finally, that wraps up our housekeeping items. It's time for our keynote speakers, Kenji and Kinuko. Please take it away.
Hi, this is Kenji. I'm a product manager working on loading and the navigation experience.
Hi, everyone. My name is Kinuko, software engineering manager working on loading and networking on a Chrome Web Platform team.
All right. Welcome to BlinkOn 14, our second virtual BlinkOn. So apparently someone decided that Mars would be the theme for this edition. And to be honest, I'm not quite sure why. Kinuko, do you have an idea of why this is the theme?
Well, I don't, but maybe it's the idea that technology evolves so fast that we might reach a point when conferences go interstellar.
That would be amazing indeed. I'm actually quite fond of science fiction, and I've been following a bit the Mars mission, but something made me really, really sad.
What's that?
Well, it's the fact that no one asked the only question that matters. Instead, folks ask things like, would you try growing potatoes on Mars? Or did you find another iguana?
They are good questions too, I guess. But okay, what's the only question that matters then?
All right. It's whether or not the Perseverance rover can run.
Doom.
Almost. The answer to that is a bit too obvious, right? I mean, anything can run Doom, even an ATM machine. The real question is whether or not it can run Chromium. And so I looked up the hardware specs for the rover. Let's have a look. So the CPU is a radiation-hardened PowerPC 750, which is the same kind of CPU that you can find in computers that were used in 1997. So I guess it's doable. Next, the CPU clock is only 200 megahertz. So I'm sure we'd agree that it's quite the challenge already. But the real struggle is not here. It's in the RAM department because the rover only has 250 megabytes of onboard memory. And while tremendous progress has been made on Chromium's memory usage, clearly getting Chromium to work with just 250 megabytes of RAM is going to require Doom God mode level of tricks.
All right. Why might not it be possible to run Chromium on a rover? We know that Chromium is used to power the UX of some of the most recent spacecraft. That's quite the achievement. and that thanks to this amazing community we have around Chromium. Speaking of the community, let's have a look at some stats. Okay, here's the graph that's showing where the participants of the BlinkOn 14 are journeying from. This is all virtual, so it may be hard for you to feel, but the people you'll be talking with are actually from all over the world.
And maybe even from Mars if we look very closely into long tail, right? Anyways, the graph doesn't show all the countries, so here's the full list that we've got. So welcome everyone, we are very excited to have you with us, including folks from the smiley face country. Speaking of where folks are from, this is another word cloud. This one is showing the participants' affiliation, and we have great diversity here, which is also like the thing that I like the most about working on web platform, the diversity of the people involved in it. It's clear that we all benefit from working together, regardless of affiliation, nationality, or background. And so we really want to make this project a welcoming place for everyone.
Okay, let's talk more about the community and look into how Blink, Chromium, and related web technologies are built by the power of the community. As you can see, both the number and the percentage of contributors who are not Googlers or not using Chromium account hit their best this year since 2018. In the last year, we had 47 more non-Google, non-Chromium contributors, and its percentage has gone up by 1.4%. Note that Google contributors have been also growing at the same time, so it's not because that the population is shrinking. For example, we had 32 more Google contributors since last year. If we split the non-Google contributors by organizations and companies, the breakdown looks like this. Here, Microsoft has the biggest number of contributors, but Intel, Igalia, and Yandex also have significant presence there too, closely followed by Opera, Samsung, and more companies. Another finding is that compared to the last year, this year we have more diversity in the community, which is great.
And looking at the commit volume, we can see that Igalia is the #1 non-Google committer, with Microsoft closing that gap quickly. Also, commits from individual contributors are significantly up compared to last year, which is also great to see. Beyond Chromium and Blink, there is plenty of work happening that also help move the web forward, whether it's from V8, DevTools, web platform tests, and much more. And as you can see from the smaller pie portion, the wider web community is even more diverse. Individual contributors drive a significant chunk of the contribution, and there are lots of companies and organizations who are super active. Igalia and Microsoft, again, top 2 contributors, but if you look closely, the WebRTC community, Lunar.G, Intel, ARM, and Samsung are very close.
Yeah. Okay, now let's take a look at what the community has been busy committing. So let me start with Microsoft, who have been making significant contributions in Chromium, B8, DevTools, and web platform tests. Their work spans from accessibility, modules, scrolling, rendering, to various new APIs and the PWA-related work. There are a lot to highlight, and we will talk about some of them later too.
Intel contributes to many projects that benefit the web. Chromium, Angle, Dawn, Vulkan, GPU, Web GPU, sorry, and so on. Some of the key areas that they have been driving or completed are listed on the right, from major to WebAssembly, SIMD, and various capabilities feature. I'm sure we'll all come to further appreciate the value of investment into web codec, media capture, given how much of our work and personal lives have started to integrate more virtual and remote aspects.
And Samsung has been also driving multiple features and work, not only in Chromium, but also in Angle and BlinkOn. They've contributed a lot to powerful capabilities like digital goods API, payment request, WebXR, as well as to the areas like screen forwarding and trusted web activities.
As we've seen in the graph, Igalia has been a long-standing key contributor to Chromium and related projects. Their work span a lot of areas, from CSS to accessibility, and even work on protocol handlers to help with decentralized web use case. They are also very active in spec and standards discussion, such as with containers queries. At the last BlinkOn, Rick Byers asked the attendees what values were most important to them. And one of the areas that many of you valued the most was around transparency and decision-making. So we've been looking into ways to improve on that. We already announced a couple months ago that Chromium contributors can now self-nominate to be an API owner. And we're starting to see interest in this area and are eager to see that translate into nomination soon. In terms of what's next, there is a group of folks who are going to review how decisions are being made and will work to clarify the role, responsibilities, and scope of our decision-making bodies, such as the API owners. They will have a breakout session today on the second slot, which is about 30 minutes after the end of the session. And if you have suggestions or questions, don't hesitate. They really want to hear from you and brainstorm solution with you. Please get your voice heard by filling up the form that you can find on the schedule. And don't worry about memorizing the link. It's over there at the Slimper link that everyone should have access to. All right.
Yeah, thanks, Kenji. That's super important. Somewhat related, let me talk a bit about inclusion. We keep reviewing our wording and languages in our code base to be inclusive. And since last year, we've made another series of intensive efforts to go through all the code base to review and fix our languages. The examples include renaming master domain, whitelist to allow list, native to host or something, and so on. I won't say that we are done what will be done, as it's an ongoing effort, but still wanted to show what we've done in 1 year. We've fixed and closed 109 code inclusion bugs. So we've talked about the community, collaboration, and the inclusion. These are super critical to Blink, Chromium, and to the web platform. But there are also a few other things we want to talk about today and during BlinkOn. It's about how the web is actually evolving and how we are approaching these. Let's take a closer look at many of the recent ways the web has been moving forward. Okay, so there are many, but let's start with security and privacy. You know, we are aiming for Mars, and these have to be the top priority thing. In last BlinkOn, we talked about origin isolation, COP and COEP, cross-origin opener policy, and the cross-origin embedder policy as a way for sites to achieve better cross-origin isolation. This year, we will start to gauge the usage of shared array buffer, which is known to make Spectre-like attack easier, only for the sites that deploy COP and COEP. In order to make this transition easier, we also shipped the reporting API for cross-origin policy and prototyping a new embedder policy called credentialless, which will be easier to deploy as it doesn't require explicit opt-in from every sub-resource. Another important improvement is that Chromium starts to restrict private network requests for sub-resources and also has closed a bunch of paths by default, as we've learned that these open paths could be attacked and can endanger our users.
On the privacy front, a lot of progress has been made. For instance, there's been a lot of activity around partitioning state. The HTTP cache partitioning launched in M85, and more is on the way, from network state to storage, service worker, and even communication API. State partitioning is actually part of a bigger privacy effort that's called Privacy Sandbox. This effort aims to create web technologies that both protect people's privacy online, but also give companies and developers the tools they need to build thriving digital businesses. We really believe that this is critical if we want to keep the web open and accessible to everyone. So let's briefly go through what's happening there. The first one I want to highlight is kinful same-site cookies, which make requests on the same registrable domain, but across scheme to be considered cross-site. That might be a bit hard to follow. So in other words, https://example.com and http://example.com are considered cross-site from a cookies perspective. Then multiple features like trust token, first-party set, and new proposal for conversion measurement and interest-based online advertising are also under experimentation. You can check out privacysandbox.com to not only learn more details, but also find how to get involved in shaping the proposals.
Okay, next, we also want to make sure that the web provides smooth, engaging, and pleasant user experiences. Let's start what we are doing in this space. So we event regions that is shipped in M90 changed tracking regions for blocking wheel event listeners. This has significantly improved the scrolling performance. Another thing that's expected to be shipping is percent-based scrolling, This provides better user experience, especially when the scroller viewport is very small. Both are driven by Microsoft contributors. I'd like to give a big congratulations to the Wheel Event Region's launch and its performance win. Okay, next. Instant and Seamless is a series of efforts that tries to make learning instant and navigation seamless for a more engaging user experience on the web. BF Cache, which might not need another explanation at this point, is a super powerful feature that enables instant back and forward navigations. This was enabled for cross-site navigations in M86, but now it's also available for same-site navigations. BF Cache for desktop is also coming next and will be on Origin trial. Shared element transitions enable seamless transitions between elements and is soon on Origin trial as well. And then early hints and prefetch and pre-rendering with speculation rules API are technologies to make next navigations fast and even instant. They are expected to become experimentable soon as well.
CSS plays a key role in the visual presentation of an experience, and there's been a ton of improvement in CSS. In particular, Igalia has been cranking the contribution here. There is so much to cover that it's very hard to pick which one you want to feature, and so hopefully I pick some that are the most interesting one. The first one consists of flow relative properties, which allow authors to set different corner border radius depending on the direction and writing mode of the page. The second one on the screen is about adding support for width and height on source element. This matches what already exists for non-picture images, such as canvas and videos. And I don't know about you, but I really like when things behave consistently because I really feel like it helps web developers focus on their priorities and not so much about the minutiae of the platform. Next up, metrics and core web vitals. Here, we'd like to highlight an update on the cumulative layout shift metric. It's really important that metrics represent the user experience through the full page lifetime. However, the team heard concern about how doing so for CLS will impact long-lived pages that are kept around for a very long time. Think about your email client, for instance. And so after a large-scale analysis, the metrics team decided to adjust the metric. So take a deep breath for the nitty-gritty details. The metrics now captures the maximum amount of cumulative shifts happening within 1 second of one another with a cap of maximum 5 seconds during the whole lifetime of the page. So think of it as like the worst of the worst. Besides this improvement to CLS, there's been a ton of great work, especially around helping developers understand and do great on these metrics.
Okay, so what's next? Let's talk about capabilities then. We humans are so creative that we want to do millions of different things on math and of course on the web too. Let's see how we are enabling these. We have a lot of new APIs that allow developers to build sites that work with various hardware peripherals like USB, Bluetooth, and other. And the new APIs include WebHID, WebShare, and the WebNFC. Gravity Sensor API also allows web apps to read and utilize 3-axis gravity force. These will enable powerful games, productivity tools, and educational applications to be built as progressive web apps. Another exciting API that is experimenting currently is Digital Goods API. This brings the power of in-app purchases to the web. This could make it easier for developers to sell digital goods on the web. So let me call out that both WebNFC and the Gravity Sensor API are largely driven by folks at Intel. Kudos and congratulations to them. And the Digital Goods API is done with great collaboration with Samsung. I would also like to give big applause to them. Thanks and congratulations. Okay, PWS are also gaining a richer, beautiful install UI and also get super convenient site settings UI on Android. You will find that web apps now feel a lot more integrated to the platform. These are launching in M92.
Identity verification and payment authentication are two critical user journeys on the web that we are investing further in. WebOTP was shipped in M84, and this year we are adding cross-origin iframe support. We are also running a second origin trial for secure payment confirmation, and this second origin trial comes with a browser prompt, which is designed to improve trust and users' understanding of the feature. The feature is also enabled for iframes to achieve a more seamless user flow and better developer ergonomics. In major and streaming land, there's been multiple new updates. Stream APIs now support BindStream, which enable build your own buffer readable streams, and WebAudio API spec is now a proposed recommendation. There are also two exciting APIs that are both in origin trial now, WebCodecs and WebTransport. WebCodecs allow JavaScript to encode and decode media stream using the browser's codec implementation, which is far more efficient than doing the same in pure JavaScript or even WebAssembly for that matter. As for WebTransport, it allows low latency client server data transfers, and by combining these two, one can write very flexible and efficient media streaming application.
Okay, multiple new features have also shipped in WebXR for immersive experience on the web. For example, you can now place virtual objects on real-world surface. As you can see the cute BlinkOn flowers on the flower in the screen. You can also check out blog and articles and the new announcements on immersiveweb.dev to learn more about it. So we talked a lot about great experience in the web, but like any platforms, we need to provide the tools, APIs, signals, and the metrics for developers to actually create such great experiences. There are multiple new features that developers would hopefully love to try. About Signal, its beloved feature that was originally added in Node. This can be useful to cancel listening to an event and the ergonomic for frameworks and libraries. Declarative shadow DOM enables the creation of shadow rules declaratively from HTML, which is very useful for server-side rendering with web components. And there are also several advancements in modules. Now you can install and import a map for your page. And you can use ES modules for service workers. And one more thing, JSON modules can now be statically imported with type assertion from M91. And the JSON one has been driven by Microsoft people. Thanks and congrats to them. And in WebAssembly and JavaScript, again, there are many exciting things. But among them, WebAssembly Shimmed is finally shipped, which allows developers to write high-performing compute-intensive applications. For example, you can only get 14 to 15 frames per second for non-GPU hand tracking systems on your laptop without Shimmed. While with Shimmed enabled, you get much smoother experience at 38 to 40 frames per second. Intel contributed a lot to the WebAssembly Shimmed launch as well. Kudos to the great contributions.
Another way to help developers make the most of the platform is to provide them with great tooling, such as DevTools. There's been a lot of new features, but let me introduce a few. There is simulated storage quota, which allows developers to override the site's quota for testing. We also have great support for Flexbox, which you probably know as like the thing that a lot of developers really like to use for layout. And so now the tools have like proper nice support for that. The last one I want to highlight is a memory inspector panel, which allows developers to inspect the content of array buffers. And that's super convenient in the context of debugging WebAssembly. I don't know about you, but this also brings back fond memories of messing up with 8-bit games with POX and whatnot back in the 80s. New capabilities are always exciting. That said, what's even more exciting is to see the progress made on web compatibility. As you may know, compatibility gaps came out as the #1 pain point in the last developer satisfaction survey. Here, Google and Microsoft are closely collaborating. And this year, Chrome and Edge, their score went up from 82 to 86. Even more impressive was the sharp increase from 65 to 79 in Safari score, which was largely thanks to contribution from Igalia around aspect ratio. So, thanks a lot for helping get those numbers up and close to each other. We are also stoked to see that you've been responding positively to the calls for using web platform tests as part of testing new features. This graph shows a nice increase of the fraction of change that use WPT. Thanks to everyone who's been putting WPT first in their approach to testing.
Okay, then lastly, let me talk a bit about our code base. Why? The code base is what most of us work on every day, and improving it affects our productivity and maybe happiness too. Let me highlight some great things there. Legacy IPCs in content directory are now nearly gone, big thanks to great contribution by Galia. And web components visa removal has reduced a surprising amount of 44,000 lines of code and 68 kilobyte binary size. This is amazing. For the legacy IPC removal, you'd want to check out the lightning talk by Galia that's happening right after this keynote. So we've covered a lot because we did a lot. Overall, we had 71 intents to ship, 40 intents to prototype, 18 intents to experiment, 13 intents to extend the experiment, and 6 intents to remove. Amazing work. So that's a wrap. I really hope that you enjoy the BlinkOn 14. Thanks everyone for being here and having us as a part of this awesome community.
We hope that you will have productive discussion with your peers and have fun during this 3 days event. And I hope to see you in the breakout session or in the Slack channel. And with that, I believe that Hara-ken, you're going to take over to introduce the lightning talk. Is that right?
Yes. So I am Hara-ken from Tokyo. So welcome everyone to the lightning talk session. Yay! So are you excited? I cannot hear anything, but I am assuming you are excited. So this time, we have 36 lightning talks. I asked all the speakers to insert one point where they can get a storm of applause. Please find the point and send a round of applause over the screen. The speaker is also watching this lightning talk session. Please use the text chat and send a heartwarming message and emoji to the speaker. All right, so are you ready? Let's get started.
Hello, BlinkOn. I am Felipe Erias from Igalia, and I am going to talk about the standard functionality for styling scrollbars that is coming to Chromium. Scrollbars are tricky UI elements because they look and they behave differently on different platforms, and authors want some control over them, but too much flexibility could increase the complexity of CSS and end up hurting the usability of websites. So CSS has been trying to cover the most useful cases in a way that is both flexible and simple. I am going to talk specifically about 3 scrollbar properties for gutters, widths, and colors. So let's see how they work. We have our content here, but when it grows a little bit, the scrollbar comes up and the whole layout changes. To prevent this, the scrollbar gutter property lets you reserve space for the scrollbar, so the scrollbar will occupy that space and the rest of the layout will remain stable. You can make it symmetrical, so the same space is added on both sides of the box, which is interesting, for example, when used on the root of the page, so all of the content is centered regardless of where the scrollbar is. If you add a header, you might also want it to be aligned with the main content, and you can also do that. And then maybe this would look nicer if the scrollbar was a little thinner. And for that, we have the scrollbar width property. You can set it to thin to get a thinner scrollbar. You can even set it to none if you want to hide the scrollbar altogether because you want to do your own thing. And then maybe this would look even nicer if the colors of the scrollbar match the rest of the UI. And for that, Scrollbar color will let you specify the color scheme used by the scrollbar. So with these three properties, authors will be able to have a lot of control over how scrollbars interact with their designs using just a few simple lines of standard CSS. Support for all of these in Chromium is getting there. The current spec for scrollbar gutter is implemented, and that's what I've shown here. So you can already try it, but bear in mind that the spec might still change a little bit. There is also an initial implementation of scrollbar width, and hopefully work on scrollbar color will start at some point in the near future. Thank you very much, and enjoy the rest of the conference.
Hi, I'm Yuki from Chrome Memory team in Tokyo. Today, I'm going to talk about LayoutObject Oilpanization project. Oilpan is a garbage collection system for Blink. C++ doesn't have a GC system, but manual memory management can cause security issues. To avoid critical security issues, Blink has its own implementation for GC. And converting non-Oilpan classes to Oilpan is called as Oilpanization. Layout was the largest non-Oilpan codebase. It is very performance sensitive and has many performance optimization, including manual lifetime management. Though we cannot simply move all the layout code to Oilpan, we decided to Oilpanize LayoutObject because it was the top source of the use after free bags in 2019, and it cost much engineering time to maintain the complicated code with manual memory management. We can avoid use after free bags by using Oilpan. Also, LayoutObject used its own memory space called layout partition. It was the last thread unsafe partition root, which was a blocker for partition alloc everywhere project. Moving LayoutObject to Oilpan solves this problem. To move layout code to Oilpan, we had 3 steps: design and implementation, then performance tests, and finally, landing and follow-ups. We prepared 48 CLs for each layout-related class and did performance tests on Pinpoint. The test results showed that there is no statistically significant regression with the important metrics for layout and rendering. Some metrics even showed improvement, but it didn't happen in the real world when we landed the changes. Now we are working on some memory-related regressions. I put some reference here, so please check my slide if you are interested. Thanks for listening.
Hi, I'm Rakina from Chrome Tokyo. Let's talk about removing DidCommitProvisionalLoadParams. First, let's review how navigation works. After we start the navigation and gather response, the browser will pick a renderer and ask it to commit the navigation. Then the renderer will process the commit and reply with DidCommitProvisionalLoadParams, which contains final info about the navigation. Now the browser considers the navigation as finished and will update session history and other stuff. Why do we have DidCommitParams? Most of navigation logic used to live in the renderer, so the browser needs to rely on it to get full and final information of the navigation. However, after please navigate, most navigation logic lives in the browser. This means the browser should have enough info and doesn't need to rely on the renderer anymore. But why is it a good idea to remove it? First, it's good for security, since the browser won't need to trust a potentially compromised renderer. Moving most navigation logic to the browser also removes lots of complexity, which helps other navigation projects like render document. Removing it sounds easy, right? Just take the calculations in the renderer and move it to the browser. But the navigation pipeline is very complex, so it's very risky to change stuff, and it's hard to be confident that we get things right. To be more confident, we decided to first test our calculations against actual navigations in the wild, before finally removing the rendered code. So the steps are: figure out how to calculate, add calculation code, test it out, then remove the params once we're confident. Figuring out how to calculate the params is simple. You just need to stare at navigation code for a while. After that, we began calculating and testing things out. But of course, we hit edge cases and bugs. Now we need to analyze the failure reports, somehow figure out what kind of navigations happened, spam the navigation dev mailing list with calls for help, write lots of documents, then fix the bug and start verifying again. So all of these started in Q4 2020. How is it going now? It's actually going pretty well. Most of the params are either removed or being verified, and we have good plans for the rest. We also found and fixed lots of existing bugs and technical debt in the navigation code. Example bugs involve lots of fun ways to navigate, like MHTML, XSLT, WebView, JavaScript URLs, redirects, error pages, and BF cache, and a bunch of other stuff, I guess. We found that most of these bugs tend to happen on complicated paths that aren't very well tested. So we also improved test coverage, because we're nice. Along the way, we also help improve HTML standards on navigation and session history. I also found that making memes is a good coping mechanism, even if only 5 other people understand it. To close up, I'd like to thank everyone in navigation dev for all of the help. There's still lots of work to be done here, so I hope they'll put up with me a little bit longer. Okay, thank you very much. Bye.
Hey everyone, my name is Joey, and today I'm going to be talking about the accent color CSS property. So the accent color CSS property lets you change the color used to render 4 different types of form controls: checkboxes, radios, ranges, and progress. As you can see in this slide, the blue color is the way we're already rendering them today. And the accent color red ones, as you can see, render the form control with red colors instead of blue colors. And you can put in any color you want into this CSS property to render it however you'd like. So the reason that we implemented this was because that pretty much every other form control can already be styled with CSS properties like color and background color. So you can see in this button element on the left, it's rendered the way it normally would be with dark mode. And on the right, I put in color red and background color green, and you can see that I can already change the color of these today. Another reason why we implemented this was because when we launched Form Controls Refresh a year ago, we changed the colors from grayscale to blue. And a lot of people didn't like the blue color, they wanted to change it to something else. And accent color enables developers to do that to their websites. An interesting problem with this feature is that since you can put in any color you want, there might not be enough contrast in between the accent color and the rest of the form control. So as you can see in this video here, as I move the color from left to right, and the form control is drawn differently, you can see that I changed the checkbox, or like the check mark, from white to black to make sure that there's enough contrast in between that accent color and the check mark so you can still actually see it. And that's kind of the way I've already implemented it today. Another possible way we could fix this is by allowing a second color to be passed into that accent color CSS property to decide what color to draw with the rest of the control. But the way it's currently specified only allows one color. And you can try it out today. I already landed the initial patch in M91, so it's available in Dev and Canary. You just got to enable the experimental web platform features flag and try it out on some of those websites I have linked here. Thank you.
Hello everyone, I'm Gyuyoung Kim from Erias. Following the last 19 talk in BlinkOn 13, I'm going to share the update of the legacy IPC conversion. Although many people already know what is the Mojo and why we need to convert them to Mojo, I would like to explain this work simply again for new people who don't know about it well. As we know, Chromium has a multiple process architecture, and it means that there are a lot of processes communicating with each other. IPC communication, which uses the named 5, has been used for the communication so far. However, as a long-term intent, Chromium team wanted to refactor Chromium into a large set of smaller services. The existing IP structure is not the best fit for the goal in terms of security, stability, and integration of a large number of components. So, the Mojo communication framework was devised. It's well known that the Mojo is about 3 times faster than the legacy IPC and 1/3 less context switching compared to the older IPC in Chromium. And also, we can remove unnecessary layers like content renderer to communicate between different processes. Besides, we can easily connect interface client and their implementations across arbitrary inter-process boundaries. So, replacing the legacy IPC with Mojo is one of the goals for Onions 2.0 and it's a prerequisite to further onion sweeping and refactorings. Igalia has many devotees working on converting the legacy IPC in content during the last year. 293 messages has been migrated and 3 IPC messages remain now. 98% has been completed since August 2019. As IPC message conversion is almost getting over in content layer at the end of this March, and now there are only 3 IPC messages related to Java bridge message. Recently, we have been working on other areas, for example, printing, extension, and read-review. 24% has been done since August 2019. Igalia has been working on migrating the legacy IPC to Mojo in other modules since BlinkOn 13. All IPC were successfully completed to migrate to Mojo in Android WebView, Media, printing modules. In printing module case, the next talk presented by Julie will explain it more detail. And now, we are working on converting in extension. Besides from that, the Java legacy IPC conversion was on hold for a while because there was some issue with the WebView API in content layer. This graph and table show the progress to convert the legacy IPC to Mojo. Thank you all people who have been working on this project in both Google and Igalia. Especially I appreciate all reviewers who have been reviewing a bunch of our CR. Thank you for your attention.
Hello everyone, I am Abhijeet. I work as a software engineer at Igalia. Today I will be presenting the status of the LACROS project. This lightning talk is a continuation of the previous talk at the BlinkOn 13 given by my colleague Antonio. Let us just recap what is a LACROS. LACROS is an architecture project to decouple the Chrome browser from the Chrome OS window manager and the system UI. The name comes from Linux and the Chrome OS. Why LACROS? The goal of the project is to have an independent browser and the Chrome OS update. The diagram on the right is a simplified architecture of the LACROS. Some of the key LACROS components are the Chrome OS built-in Wayland Compositor XO and the native Wayland support on the top of Ozone. Scope of the project includes adding a Chrome OS specific capabilities to Chromium Wayland so that it acts like a Chrome web browser. Let's see some updates. The LACROS team at Igalia is working on the various features to have a UI parity between the Chrome and the LACROS Chrome as below. This was the status of the LACROS Chrome during the BlinkOn 13. Let's see the current status. We are pretty much closer to the Chrome UI. And this is the comparison video between the Chrome and the LACROS Chrome. What is next? We are working on the tab strip support, fractional scaling for high DPI, web UI tab strip. Thank you. And if you have any question, please send an email to the LACROS team.
Hi, I'm Julie from Igalia. I'll talk about module conversion in printing, which I work. Here are some background. Chromium replaces legacy IPCs with Mojo, and Igalia has worked on it. and I started to work on printing, Jess already had converted all of the messages sent from the browser to the renderer. So I started to work on the rest of IPCs. Printing has some configuration and multiple entrance points. Jess can trigger printing using window.print. Keyboard shortcut can trigger printing as well. And you can also print a page through context menu or 3-dot menu. Normally on desktop, Chromium supports preview, but you can disable it with command line switch or keyboard shortcut. Printing also has some specific implementation for headless or Android web view. Yes, whenever I touched the code, I needed to verify it with these configurations. As you can see from the screen, print render frame helper sent IPC messages to several places in the browser. With Mojo, I introduced two Mojo interfaces, Print Manager Host and Print Preview UI. Frame Helper has associated remote for them, and in the browser, Print Manager and Print Preview UI are receivers for them. So Frame Helper can send Mojo messages through them to the browser. Preview ID structure had a Preview ID and a Request ID. When a Preview UI is opened, Preview ID is acquired. While it's opened, the preview request could happen multiple times, for instance, when some configuration is updated. So it has a request ID. When printing used legacy IPCs, it had to pass that information to the browser to know where the message is from. After converting IPC to Mojo, the structure is not required anymore because it bound when the preview UI is opened and reset when the preview UI is closed. One of the challenging part was how to change messages that used enable message pumping. There is a function that supports to pump message while a sync message is waiting for the reply. It was not used in many places because it could increase complexity during IPC, and the messages used it or the use cases had been cleaned up already. But printing used it with two legacy IPCs. Thanks to Ken, we could use the nested run loop. I defined the sync messages and passed the callback that quit the run loop. Then the nested run loop allows running tasks while it's waiting for a reply. When we used it, we should not forget to quit the run loop on the disconnection if it's running. Through this task, I cleaned preview ID structure, legacy IPC messages, handler, filter, and messages for printing. I also cleaned up enable message pumping. I'd like to say thanks to all who helped this work completed. I'm happy to share that the printing messages under the component has been fully converted to Mojo.
Hi, I'm Miyoung Shin from Igalia. I'd like to introduce how to catch the directionality of the element in Blink. Let's understand what the directionality of the element is first. All elements have own directionality. We can set the DI attribute to the element expressly. Okay, let's run it quickly. The default direction is LTR. LTR, RTL, LTR, RTL. Now we understand all directionality. Why do you need to catch the directionality of the element? Element didn't have own directionality itself. Instead, it depends on the direction field in compute style. And we didn't know the directionality of the element if compute style is not created yet or failed. Also, we use it with directionality property of the CSS in compute style. There are some cases when the directionality of the element needs to be recalculated if there is no change in the element. Also, it needs to be recalculated for DIF should class implementation. So we need to catch it for functionality and performance. How to catch the directionality of the element? There is the rule like if the attribute has LTR or RTL, we update the directionality of the element and its descendant immediately. If the attribute has auto, we reserve the directionality and update the element and its descendant immediately. If the element has no valid value, we set the directionality of its parent to it and before passing children. If the child is inserted with no valid value, we set the directionality of its parent to it. We complete catching the directionality of all elements before calculating the style. There are two cases that require some exception of the rule. They are slot and shadow rule. The spec is still unclear for them and it's under the discussion. Besides, we have a few other things to highlight in conjunction with this subject. We support the DI should class as experimental feature since M89. And we improved the performance for their auto by reducing the calculation of the directionality. In case of replacing the text node like from A to B, we improved to over 10%. In case of inserting of the text node like A, B, C, we have improved over 200%. Also, we fixed the old bug. Unfortunately, we don't have measuring data for this casting directly, but I believe it would have helped improve performance, obviously, because it uses calculations. Thanks.
Hi, I'm Alex from Yamada. Let me tell you some news about Ozone. The ozone layer lies below Aura. It wraps low-level input and graphics, and integrates with the desktop environment. Ozone had been introduced in Chrome OS to ease porting it to a variety of platforms that Chrome OS targets, primarily the embedded ones. We at Xida are adapting Ozone for the desktop Chrome, with the main goal of implementing support for Wayland. During previous BlinkOns, we shared our progress and intermediate milestones. Here is the retrospective. In 2019, nothing was ready, and we had a lot of work to do. On the desktop Chrome, Ozone could only be enabled through build flags, and therefore end users couldn't try it without building the custom version. That limited the potential audience to enthusiasts capable of building Chrome. However, we got some feeling that we should be able to deliver Ozone in some observable future. In 2020, that happened. We included Ozone into the official desktop build, which made it available to every user of Chrome on Linux. The default mode was, and still is, non-Ozone, but anyone could try Ozone by passing a couple of command line flags. The next goal was starting the Finch trial, which would activate the new implementation for users without their explicit request. So, where are we now? We are there. Ozone X11 has reached feature parity with non-Ozone. All tests pass. Ozone is ready to launch. Finch trials are currently on hold because of some problems unrelated to Ozone, but as soon as these problems are resolved, we expect our trial to start. This has been a long project, and now it's reaching the major milestone. Of course, starting the Finch trial will not be the end of our work. The next steps are maintaining the trial and fixing the issues that may come, deprecating the old code and removing the obsolete logic, and going on with the Wayland, which is our primary objective. So there will be more Ozone news in the future BlinkOns. For those of you who want to try Ozone before it becomes the default, we have added the switch for Ozone X11 onto Chrome flags. For Wayland, enable it via command line. Finally, here is the incomplete list of people who work on Ozone and helps with the review. Thank you for your attention.
Hello everyone, my name is Xida, and I want to talk about composite background color animation. As the name implies, the project is to run the background color animation on the composite thread. Why do we want to do that? Well, background color is one of the most animated properties, and we have metrics to show that in general, when an animation runs on the composite thread, it is much smoother than running it on the main thread. Please refer to my previous BlinkOn talk for technical details about this project. The current status of this project is that we are ready to finish. Well, that's just the short story. The long story is we did the finish once and we fixed a lot of bugs. So today I'm going to talk about three major issues that we have resolved. The first issue is that paint and composite must agree with each other. In Chrome's rendering pipeline, we paint the element first, and during the compositing stage, we try to check whether the animation on that element can be composited or not. Well, what if these two stages doesn't agree with each other? For example, during the paint stage, if we failed to collect the information of the animation, but during the compositing stage, we said, well, the animation can start running on a compositor, then something will be wrong. So we have to handle that case, and we have to also handle the case the other way around. That is already resolved right now. The second major problem is to handle non-visible frames. This can happen in many cases. For example, if the element is 0 size, then it's not visible. If the element is really far away from the current viewport, it's not visible. If the animation starts from a transparent color to a non-transparent color, then the initial frame is also not visible. In all these cases, we will very likely skip the paint of the element. And from previously, we have mentioned that the paint and the compositing stage must agree with each other. So we have to handle this case too. A third major issue is that we have to make sure that repaint is triggered. We could have the case that a background color animation is already running on a compositor thread, and in the next frame, a keyframe of that animation change, or we just switch to a completely new animation and make it attached to that element. In both cases, we have to make sure that we trigger the repaint so that we can collect the information of the new animation, and so that we can run the new animation on the compositor thread. So all these three major issues have been resolved, and we are ready to finish now. We really hope that we will see a really positive impact of this project very soon. And that'll be all. Thank you, everyone.
My name is Jordan Taylor, and this is my presentation on scroll timelines. Let's start with what a timeline is. Timelines are used to determine what an animation should show on the screen at any given point. Previously, there existed one kind of timeline, the document timeline. Document timelines start at 0 and begin ticking as soon as the page loads, and continue increasing at a constant rate. Multiple animations can use the same timeline, and additional timelines can be created at any time. So what is a scroll timeline? A scroll timeline uses a scroller to determine the current state of an animation, as opposed to a constantly ticking time. It operates in a similar way to dragging the timeline for a video on YouTube or Netflix. The animation only updates as the user scrolls back and forth, causing the animation to progress either forwards or backwards. Scroll timelines only update when the scroller has changed, as opposed to updating every frame like a document timeline does. Why do we need scroll timelines? Developers and libraries on the web are writing janky hacks to enable things like parallax and other scroll-based animations, but they are execution heavy and bog down the main thread and make for an overall bad experience. Implementing scroll timelines natively allows us to optimize and provide developers with better APIs and tools to accomplish what they want. We get performance gains because we update less frequently and cause less pressure on the main thread. What have we changed already? We abstracted document timeline into an animation timeline interface for animations to use, since they shouldn't need to know what kind of timeline is driving them. Scroll timeline required that we add phases to timelines to help define what occurs at edge cases around the beginning and end of an animation. We refactored animation to handle changes to underlying timelines and new phases, added hold phase to animations to handle pausing. We refactored animation effects to receive and handle new phase data. We refactored animation to handle timeline transitions between active and inactive. A timeline can become inactive when its scroller becomes non-scrollable, hidden, or removed. It didn't make sense to associate animation current time with scroll timeline time. Instead, a new concept was introduced, the progress-based timeline. Within the new concept, scroll timeline and scroll animation time properties were defined as percentages rather than time values. Here are a few of the bigger problems that we ran into. Because of so many moving parts in the animation system, it took a lot of finesse to develop the right solutions to the problems we ran into, trying to design how scroll timelines should integrate with existing systems and behaviors. Determining the model for how we were going to handle inactive timelines. Defining the new timeline phases and how to handle each edge case. Cross-company collaboration and online discussion on GitHub issues allowed us to narrow down possible solutions. We reduced complexity and solved several problems at once by getting rid of timeline fill mode and adding timeline phases. How and where to convert from time-based values to progress-based values when using scroll timelines. Our ongoing work includes converting scroll timelines to be progress-based. Remove the need for the arbitrary time range value from scroll timelines. Allow for multiple scroll offsets, that's delay and end delay. Thank you very much.
Hello, my name is Behdad, and I want to talk about investigating rendering pipeline using traces. In the rendering pipeline, we have multiple processes that would be doing different parts of the work. We would start with this thread, display compositor, sending a begin frame to CC, composite thread, then we do some updates there, like a scrolling or composite thread animations. We'll pass that to the main thread. If you have any main thread updates, the work on Blink will be done there. Stuff like layout or main thread animation or JavaScript code, things will be committed, activated, raster is done, then submitted to GP process, and all the other steps to presentation. From this chart, the numbers show how we map those to the breakdowns of the trace event that we have in the traces, which would look like these. They are called pipeline reporter, and we will have one pipeline reporter per frame at least. And the latency of each of those segments shows how much work we spent on that thread and that part of the code. So in this first one, it's kind of balanced. Every piece of the breakdown is taking some amount of time. In the second one, we don't have a big send begin mainframe to commit. Maybe we don't have any. Maybe there is no main thread update to work to be done. And then, but we have beginning pull frame, which is all the compositor thread updates, and then we have submit to the GPU process. And on this last example, we are only spending the time on the GPU process. Maybe GPU process is busy, has many things to work on. And in this last example, we can see how all of these pipeline reporters together would create different scenarios in the trace and the interaction that the page is doing. For example, on this first one, we have two pipeline reporters which are started at the same time. And if you look into the arguments, they have the same ID. This means that by the time we wanted to submit this frame, the main thread is not done with the updates of that frame. So what we do, we duplicate the reporter because we are already showing some of the updates from compositor thread while we are still working on another part of the updates on the main thread. So we will just submit whatever we have at the moment, and all the other frames from afterward, they can't have send begin main frame to commit because main thread is busy working on a previous frame. And we will go on until that frame is done, and then main thread is free again to work on the main thread updates. And as the same reason, it would be that we have a vsync here, we start working on that frame, but by the time we want to get on the second vsync and start working on the second frame, the CC, the compositor thread, is done with the work, but the GPU is still processing the previous frame. So we would have a frame being shown after 33 milliseconds instead of 16 milliseconds. We kind of miss the deadline. We will show the update, but with a bit of latency. And also, this would show us that, for example, in a specific timeline, where this line is drawn, we are working at the same time on 3 different frames. One is on the earliest frame, being worked on the main thread updates on the main thread. We have another frame, which is a bit older, one vsyncs before, which we have the compositor thread updates, but the GPU is working on it, and a newer frame that we are right now working on its compositor thread updates. I hope that helps with the investigation of the traces that you have, and thank you.
All right, so that's it for today. So thank you very much. So please send a round of applause to all the speakers again. All right, finish. So see you tomorrow at 3:30 p.m. PST. So thank you very much.
Thank you, everyone. Hope you enjoyed everything so far. We don't have any further announcements to make at this time, so please get ready for kicking off the talk sessions, which will begin shortly. As always, you can consult the FAQ for the up-to-date scheduling information.